let's talk about functions. Function notation is when you have this equation, something like this, f of x equals 2x minus 5, and you're plugging in a number. So everywhere you see x, you're going to plug that number in. So, for example, f of 3 would be 2 times 3 minus 5, which is 6 minus 5, which is 1. Now, we're learning something a little bit different today. We're going to have to take a function that's within another function. So you'll see it written as this, or this. They all mean this. They all mean very similar things. They don't mean the exact same thing. F of g of x is actually f of g of x. That's what, those are the same. Those are actually the same. And then g of f of x is equal to g o f x. And that's how you say it. It's g of f of x or f of g of x, depending on what order it's in. And the key here is just to make sure you're going from the inside out. You're going to do what's on the inside first, and then you're going to do the outer function. And remember, that's like, it's an operation. It's things that we're actually doing to the numbers. So I'm going to give you a bunch of examples, and hopefully this kind of gets that point across. So first, in example 1, we're evaluating f of g of 2. That's how you read that, which means we're first finding g of 2. To find a g of 2, we're going to go to our g function. We're going to go to where 2 is, and we're going to come down here to where it touches the graph, which would be at -6. So this is actually equal to f of -6 because g of 2 is -6. We're plugging it in. Now we're going to find f of -6, and you do that the same way that you always find f of a number. You're going to go to the graph just like we did for the g, but now we're going to f, which is over here. We're going to go to -6. We're going to come down to the graph where it touches -6, and we get -3. So the answer here is -3, and that's it. When you're given a graph, these are actually fairly straightforward problems. When we're given equations, we're going to have to manipulate some things. So let's do some like that. So here we've got 5 examples, and my goal is to make this video less than 10 minutes, so I'm going to have to talk fast. The first thing we need to do is find the inner function. So to find g of -4, we're going to take -4 and plug it in everywhere into g that we see in x. So we're going to have -4 squared in parentheses plus 5 times -4 plus 4. That's the g part. And then we're still going to end up taking that and plugging it into f. So that outer function is still going to be there. All we did was find g of -4. Now we have to simplify that, because if we don't simplify it, we're not going to be able to find what f of whatever that number is. -4 squared is 16. 5 times -4 is -20. So we have that, which means, well, -20 plus 16 plus 4 is actually 0. So this is just f of 0. F of 0 means that we're going to take 0 and we're going to plug it in here for x. So f of 0 is 0 plus 3, which is just 3. And that's the answer. It is very possible to find f of a number, or g of a number. So B is not a typo. It is exactly what I wanted it to be. The first thing we're going to do is find that inner function. F of 2 is plugging 2 in right there for x. So it's 2 plus 3. And we're finding f of that number. Well, we're intelligent people, right? We can figure out that 2 plus 3 is 5. So f of 5 is what we're really finding, and that'll be 5 plus 3, because again, we're going to take that 5, we're going to plug it in right there, where the x is in our problem. So because x is right here, 5 goes right there. 5 plus 3 is 8, so this ends up being just 8, and you're done. F of 0, we're using that same equation, right? We're plugging it in for x. So we're finding g of 0 plus 3. Because 0 plus 3 is what we get when we plug 0 in for x. Well, 0 plus 3 is 3, so we're really just finding g of 3. G of 3 means that we're going to take 3 and plug it into g. So we're going to have 3 squared. Remember, anytime you plug something in, you put it in parentheses. 3 squared is 9. 5 times 3 is 15. Plus 4, and that's 28. So that's the answer. Now, D and E look a little bit different, but it's very, very, very possible to find those answers. The difference is that now we're not plugging in a number, we're plugging in a function. So we'll plug one function into the other. So if we're plugging G into F, because G is within F, that means we're going to take this entire equation and plug it in where X is. So, so let me make G red. So let's do that and that. So x plus 3 is what we started with. So we'll have just x plus 3. But in the where x is our function g. So we'll have x squared plus 5x plus 4. To simplify that, math says, oh, well, all you have to do is combine like terms, because this is a 1, so you would distribute 1, which doesn't change the problem. So it's really just x squared plus 5x plus 4 plus 3, which is x squared plus 5x plus 7. For the other one, we're going the other way. So now we're going to take our f of x, we're going to plug it in here and here, and don't forget that that is squared. So it'll be x plus 3, so something squared, plus 5 times something, plus 4, and that something is our x plus 3. Now you all took Algebra 1, which means you should all know that x plus 3 squared looks like this. It is x plus 3 times x plus 3. Then we have 5x plus 3 plus 4, and we're going to have to double distribute this. So it's x times x, which is x squared. 3x is 3x, and 3 times 3 is 9. Now we distribute that 5, so you have 5x, 5 times 3 is 15, plus 4. Now we combine like terms. So we have 1x squared. We have our x's here. So 3 plus 3 plus 15, 3 plus 3 plus 5 is 11x. And then 9 plus 15 plus 4 is 28. So that is the answer. Now, what if we have a combination of these things to use? Not a big deal. We can do this. This is example 3, and we'll find f of g of 2. So the first thing we find is g of 2. Well, g of 2, according to this table, because the g is in the table, g of 2 is going to be 0. So it's really f of 0. Well, f is over here. So we're going to go where 0 is. We're going to go to the graph, and that is -6. So it's just -6. So it's even easier when you don't have to deal with equations. For the next problem, we're finding g of 3. So let's start with g of 3. G of 3 is -1. So we're going to find g of -1. G of -1, according to this table, is 1. So that's the answer. Hey, look, there's 3 functions here. That's okay. We can do that. H of 2. H of 2 is 2 times 2 minus 1. 2 times 2 is 4, minus 1 is 3. So we're really finding g of 3, and then f of that. G of 3 is -1, so f of -1 is really what we're finding. F of -1 means we have to come to this graph. Hey, look, that's -6, and that's it. Finally, I want you to imagine this is a composition of functions. So if this problem right here is a composition of functions, then that means that there's a function inside of another function. The function that is inside, that's g. The outer function, so we're going to separate them essentially, right? We have the inner function, that's sine. So that means g of x in this case is sine x. So now I want you to imagine now that's just x. And what we have left over, that's our outer function. So our outer function in this case is 1 over x. All right, and that was the original problem. Same thing for b. We have 6x. That's on the inside. So that means g of x is the inner function 6x. Then I want you to imagine that now that's just the letter x, because I've already accounted for that. So my outer function is what f of x is, and that's x to the 8th power, because that's what's left over. Okay, one more. Our inner function here is 1 over x, because 1 over x is inside of the square root. And then if I change that and just think of that as x, then the outer function is the square root of x.